vacation? Yes, can somebody recollect? Yeah, quick. Hello?
So we studied about big sampling procedure.
Okay. Okay, so we started with the structure of the wheat kernel and method for gradation we started. So the first step in gradation is sampling, and this is done by a Bonner divider. So prior to that, as I already told you, after sampling, we go for checking some sort of visual checking. Like again, I think when you go for analysis or quality parameters, we have some physical parameters. Physical parameters meaning like say the observing, like the structure, the color, smell, weight, etc. These are the physical parameters. Chemical parameters, of course, the nitrogen content or the gluten and all, which we will see later. This is common to every other thing also. So if you take even rice, I think it's the same thing. First you observe the color, the length of it, the breadth of it. I think you have studied that. So generally, varieties vary depending on what is called as the length to breadth ratio. I think this I already told you. So in the case of rice, if you remember, you can differentiate a basmati rice with our punni or any other thing. So in the case of say basmati, you can observe that the length is much long, greater than the breadth. So this is what are called as the slender varieties. And when you consider the say punni or other things, you observe that the length and the breadth are almost same. So this we call as the bold varieties, etc. So when the length to breadth is greater than one, that is when the length is more than the breadth, we call them as slender varieties. And when they are almost equal, you call it as a bold varieties, etc. Okay, so if you see here, basically what we see is that one of the thing is the objectionable odor which is possible, because how is it possible? Normally after harvest they are stored in bags. So during the storage, when there is a good amount of, there's always be a good amount of moisture, which might lead to say fungal growth and other things that will lead to a particular smell. Other thing is, if the storage is not proper, that is, it goes from the farm to a storage house, then it goes to the it goes to the industry, or in the industry itself it's stored for a longer, or it's for a certain period of time prior to milling or grinding. So during this storage period, when there is not no proper, when there is no proper conditions observed, you can also have rodents. We normally call it as pests. Which are the pests? These pests are those which are not wanted by any, which are foreign to the particular grain. So pests can be classified as say something like microbial pests. So whatever you have read in the earlier semesters regarding food microbiology, right? Like your fungi or bacteria or yeast, they are also called as pests. So these are microbial pests. The other things are insects. You normally see, again, I think you have noted, in rice and other things, you can see small insects which are found. So insects are other types of pests. The third variety is rodents. You obviously see a lot of the storage is not proper. You see rats, getting into a bin and things like that, and their excreta, obviously, has a certain disadvantage. Then, and of course, you have humans willfully getting in things like that. Okay, so when you consider wheat. One thing is the foul odor, which can be because of live insects, etc. Live insects occur, I think already you have the weevils and other things which we observe. So one thing is insect infestation. Of course, you can also see about fungal infestation because you can see it as strands where one grain is uh, linked to the other by thin strands and things like that. Okay. So after passing the preliminary steps, of course, you go for your boner divider, which you have already seen. So normally, amount of 1.3 kg is taken for the work and the file sample. What I already told you is that file sample is one which is kept for reference to for a certain period of time. It can be 3 months, it can be 6 months. Why? I think I already explained you earlier. When there is a problem with the quality of the final product, or sometimes that is biscuit or other things, or when complaints arise regarding the quality of the flour itself. For example, if it is going to be milled as atta, in that when customers have a problem with the atta, saying that it is not proper, this is not coming, then they check with the file sample. Work sample is one where it is worked. So we do all the analysis with the work sample, like whatever we will be seeing subsequently. And the final sample is kept for reference. So what they do when the complaint comes, they see for the reference, the batch date, the hour, etc. They refer the whatever readings or observations made
சார்
for the yes.
சார் உங்க ஸ்கிரீன் பிளாக்கா இருக்கு சார்.
Black இருக்கா?
ஆமா சார்.
ஐயா ஸ்பீக் மினிட்.
ஓகே சார், இப்போ ஓகே.
இப்போ ஓகேயா? இது என்ன ஃபுல் ஸ்க்ரீன் வச்சா வரலையா அப்போ?
ஃபுல் ஸ்க்ரீன் வச்சிருந்தீங்களா?
ஆமா.
மறுபடியும் வச்சு பாருங்க.
ஜஸ்ட் இப்போ
இப்போ வரல சார்.
அடடா. ஓகே. So looks like full screen is not working.
எஸ் சார். ஜூம் இன் பண்ண முடிஞ்சா வேணா பண்ணிருங்க சார்.
Let us see. Is it is coming? இப்போ தெரியுதா? ஹலோ.
No, sir. ஓகே.
overall. Is it fine now? இதெல்லாம் வரும் இல்லையா? Are you able to see it now?
Yes, sir.
Okay. So, how about now? No.
No, sir.
Okay, so as I already told you, the sample to be tested is taken as 1.3 kg, and you have what is called as the work and the file sample. File sample is kept for reference, whereas the work sample is what we do the analysis with. File sample, as I already told you, is kept for reference because at a later stage, when there is a problem arising because of the particular batch related to the product or otherwise, then this reports of the work sample is taken and then done. So this sampling procedure is common for every industry. Now, in the case of, say, a soft drink industry, this might be something like 10 bottles or 20 bottles, etc., which are kept for a certain period of time. Why? When I think you have complaints. For example, in the case of biscuit itself, there have been reports where where customers have reported thin strands of rope found or a nut or a nail found. Similarly, I think there were complaints about net or nail in the soft drink or carbonated beverage bottle, etc. Now, how do they find out where is the problem with? They take the batch number, which is always printed in the bag. So with that, then they go for the readings of the work sample. Then they check again with the file sample to see whether there was any problem. Either is it because of the raw material or no, this is work sample. If they to find out whether there has been any problem with the raw material itself. Now, similarly, samples are also kept subsequently after the other processes are done. For example, milling or grinding or things like that. So at each of the stages, samples are kept to know whether to ensure that the standard quality is maintained. Okay, so work sample is used, as I already told you, file sample is maintained for a period of 90 days after the inspection is completed. So this is the thing, this is what I told. Okay. I think we have already talked about the Boner divider. The other thing is the test weight per bushel. This is again, and sorry again for repeating, the test weight of a known number of grains is a standard followed both for rice, wheat, and even millets, etc. Now again, what one is, as I already told you, the length to breadth ratio. Second is the weight. So what is the weight of the particular this thing is also found out. Why this signifies once the moisture content, because again we would see that a fresh one as a thing has a higher amount of moisture, and as the grain matures the moisture level comes down. Similarly, the fresh one has a higher amount of raw starch, which we'll see later. Okay, the starch is very low, and subsequently the starch is converted to a compact form. Now, what is the significance of say starch? If it is very raw, then again, sorry for the comparison. In the case of rice, you would have observed that in your house they prefer the old rice as compared to new freshly harvested rice. The reason being that in the case of fresh rice, starch is just formed. So as a result, when it's cooked, it becomes very pasty and things like that. Whereas once maturation is allowed, when it is kept for a longer time, the starch is stored in the granules, and as a result, the pastiness comes down. So starch content is the same, but then the pastiness and other things are less. Other thing is again, in the fresh rice, you have a higher amount of glucose. I think you know that, glucose is the raw form, which is then converted to starch during the period of storage or while the plant grows. So again, uh, mature ones have a high amount of starch as compared to glucose, or the reducing sugar or dextrose equivalent, as you have already known, is higher in the case of raw fresh rice as compared to mature rice. Okay. Now, one thing is the test weight per bushel, where a known size of the, now what is the significance is, though they say it is weight, it also considers the volume. How do I do it? I take a known cylinder or a vessel of a known volume. For example, I can, in our lab, if we want to do, I can take sort of 100 ml beaker or a 10 ml beaker, etc. So what I do, I take the sample, fill it till the brim, and then I find out the weight of it. So I know the volume, I know the weight. So weight by volume gives the density. Now, what is the significance? I already told you, some of the varieties have a lower density. And one more thing, if you consider the raw and the mature varieties, in the case of raw rice or raw wheat, since the structure is just formed, there will be a lot of space available, vacuoles as you call, available. So this means that the number of grains, okay, the number of grains for a particular weight will be more. Whereas when you consider the mature grains, since it is very compact, there is no vacuole. Vacuole is a whole vacuum, as you know, in the case of a cell. Now, when the structure is a bit more compact when it comes to the mature grain. So what is going to happen? The number of grains for a known weight will be less. So that is the thing. So here it is based on the 1.3 kg of wheat cut from the representative. As I already told you, the test weight per bushel is based on 1 liter of the capacity. Now, in a lab, you can do it for a lesser capacity also. Okay. Now, here, what we do, a modification in the lab that we normally do is that we take the weight of 100 kernels or 1000 kernels, which is again a better indicator. Now, what I do, normally, I take 100, I literally count 100 or 1000 grains. I find the weight of it. I also find the length and breadth of it. Now, how much times do I repeat? I should repeat at least 10 times and take an average of it to find out the actual density of the grain. Now, again, I think, sorry for repetition, what is the significance of all these things? Be it rice or be it wheat, they are subsequently subjected to the milling process. During the milling process, even the structure is proper, then the losses are less. What do you mean by losses? The brokens. Because when I'm going to sell rice, I sell it as a whole grain. When I sell wheat, I have to sell it as a whole wheat. Normally, when the number of broken kernels are much higher, you obviously know that the cost that this a lot gains will be much less. So for a industry or for the manufacturer or the processor, it is always better that he has less amount of these brokens and the other things. So actually you cannot call it as a loss, but loss in terms of full or whole grain. Fine. So the test weight per bushel or number of weight of 100 kernels, etc., as commonly we call it, is one of the methods of finding out the density. Now, this is normally standard for each of the varieties that we use. Okay. Okay, so this how it is done. Now, how it is done, the same way, I think, have you done your determination of apparent density and actual density in the lab, in a food engineering lab? Hello?
No, sir.
So normally, what is done is to check the bulk density. I take, as I already told you, I might take something like a 100 ml cylinder or something. This 100 ml measuring cylinder, what I do, I fill it. After filling, what I do, I note the volume of it. I take a known weight. For example, I might be taking something like 100 grams. Okay, this 100 grams. I'll pour it on the measuring cylinder and start using and find out whatever is the volume occupied. I note the volume. After that, then I tap it or tapped density as it's called. Why tap density? To ensure that the grains are actually arranged properly. So in this case, what I do, I tap it for a standard time, and then I go for finding out the bulk density. So this is how I do for bulk density. Let me see if I can get some this thing. The procedure is the same whether you do it for whether you do it for rice or wheat or a flour or even sand, etc. Okay. Let me see whether something is possible.
Hello.
Is it visible now?
Friends, today we are going to define flow property of a given sample of powder.
Is it visible?
That is bulk density, tap density and angle of repose. Now for bulk density, we require
This the equipment which is normally used. If this is not there, we can as well use
bulk
using a
density
hand.
apparatus and digital weighing balance for weighing the powder. Now for bulk density, we first weigh the sample of the powder. So here I have already weighed powder, that is 16 gram. Now we will transfer this powder into the measuring cylinder and check the bulk volume.
So the volume is checked first, untapped volume as we call it. Now here they have taken, I think, 25 ml or something cylinder. You can also take a 100 ml as the case may be, because the larger the volume of the cylinder, the more accurate the results will be.
After transferring the powder into the cylinder, tap the cylinder manually for 3 times and then after measure the bulk volume. Bulk volume is around 35 ml. Now we will record this value of bulk volume. Now we transfer this value of mass and volume into the formula of bulk density, that is mass by bulk volume. So from that we will calculate the bulk density. Now for tap density, we need to tap this cylinder for around 100 times so that powder will settle properly in this measuring cylinder and we will calculate the tap volume. So for that we have to transfer the cylinder into the apparatus, then we have to on this bulk density apparatus, set the time period for around 20 minutes and tap will be started.
Here actually the number of tappings per minute and all is given by the standard AOAC.
This tapping continues, the powder will settle and volume will decrease. Tap volume is always less than bulk volume. So, by calculating this tap volume, now we will transfer this value into the tap density formula, that is mass upon tap volume, and from that we will calculate the tap density. So from this method we can determine bulk and tap density of different powders and for production of tablets. Now we will calculate the another flow property of powder, that is angle of repose. For this we require burette stand, clean and dry
We have done this in the engineering
funnel,
lab,
graph
right?
paper and sample of powder. So for this we will first of all attach the funnel to the burette stand, and the distance between the tip of the end of the funnel and bottom is 2 cm, that is height. Now after this, we will transfer the powder into the funnel by placing a thumb at the end of the funnel so that powder will not flow. By lightly tapping the funnel, the powder will pass through the funnel and form a heap of powder. After passing through the funnel, the powder will form a pile at the bottom, and we have to pass the powder until the tip of the pile touches the end of the funnel. So after that, you have to form a circle around the pile of the funnel. Draw a circle around the pile of the funnel such that maximum powder will come inside the circle. After that, remove the powder and calculate the diameter of the circle. Now here diameter is 4.2 centimeter. Take a diameter from different points. This is also 4.1 centimeter and 4.1 centimeter. So we will record the diameters 3 times, that is 4.2, 4.1 and 4.1 centimeter. Now we will take the average of the diameter, and from average we will calculate the radius. So now by calculating radius and height, we will place this value into the angle of repose formula, that is tan theta is height upon radius. Now height is 2 centimeter, that is distance of a funnel from the bottom, that is 2 centimeter, and radius will be around 2 centimeter. So we will place this value into the formula and we will calculate the theta, that is angle of repose, and we will compare the theta value with the reference flow property and angle of repose table, and we will determine the flow property of the powder. So from these two methods we can determine bulk density, depth density and angle of repose of a given sample of powder.
Okay, now coming back to our presentation. So are you able to see?
Yes, sir.
Okay, so this I think we can move away. So this is for um, again what she was telling, almost the same thing. This is for weight per bushel. Now, as I already told you, in the case of finding out the bulk density, as it is called, a known weight is taken in a vessel or a container of a known volume. And see, if you see here, they flatten it out to find out the volume of it. Okay, so this is it. The other things are shrunken and broken kernels. This is what I already told you. During now in this, the shrunken and the broken kernels is again a grading factor. Why? When there are broken kernels, it will lead to a higher loss of yield as a flour or as the case may be. Now, how do these broken kernels find during harvesting? During rough harvesting, of course, the broken kernel is an indicator that the kernel is raw, because as I already told you, a raw kernel, a development kernel has a lot of vacuoles. As a result, then it easily breaks. Whereas once the grain starts maturing, it starts toughening up. And shrunken kernel is an indicator of the climatic condition to which the kernel has been subjected. Obviously, then when there is a difference or variation in the temperature in the day and the night, obviously then there can be a greater amount of shrunken kernels. Okay, so this is the thing. So the machine used to sieve the samples, again, how is it done? By sieving. So it shakes the sieve 30 times from side to side, whatever our what to say, grandmothers and mothers used to do. The same thing. It's basically sieving of a particular size, so that then whatever the shrunken and the broken kernels are there, got. So how do I do it? I have taken a known weight of the sample, for example, 100 grams or 1 kg. After sieving, I think you have done this also, no, in the lab? No.
No, sir.
Sieving in the fourth semester, what did you do? What are the labs you did in the fourth semester? Normally this comes in the fourth semester, right? No, I don't know, because you have the sieve analyzer and the sieve separators. No, so what is normally done, you'll be doing is that you will pass the flour to it, and then it's allowed to sieve. So during the sieving, you have variations. Sieves are arranged based on the varying sieve size. Now, one side is a sieve analyzer which you would have viewed in your chemical engineering lab. Similarly, you also have sort of a sieving machine in the R&D lab, which sieves, but not which sieves for varying sieve sizes. Now, what I do, for example, as I already told you, I might take 100 or 1 kg of the sample, I pass it through the sieve, and each of the whatever comes out of each of the sieve is collected. So what I do, similarly, as I already told you, the broken kernels, for example, if I taken 1 kg, and if the broken kernels are something like 100 grams, so the percentage of broken kernels is say 10%, etc. So here they are told a 250 grams. So accordingly, then the what to say, things will the calculation varies. Fine. Okay. Then damaged kernels. These are either because of heat or total damage, and these are separated. So one thing, you have shrunken and broken kernels, heat damaged kernels. How is it happening? Again, I think normally in the case of harvesting, sometimes in here and also sugarcane and all, sometimes they burn the grass to what to say, to aid the process of harvesting. So during that case, then there will be what to say, heat damage is observed. In fact, it's a similar thing you will be also seeing in the sugarcane also. So what is done? 50, it is again, these are visual method, that is by taking a known weight, they are checked for heat damage and the other damages like brokens, etc., to find out the thing. So whether any kernel has been materially discolored or damaged by physical or biological factors. Physical factors, heat and things, etc. Biological factors, when again, as I said, when there is an insect infestation or a microbial infestation, it's obvious that a certain the color gets changed. So that is again determined. So one thing is the bulk density, weight per bushel, then the broken kernels and damaged kernels. These are some of the factors to grade. Presence of foreign matter. Of course, what are the foreign matters in this case? You can have grass, you can have excreta of, if it is not properly stored, the excreta of your rodents and other things. So these can be done. So, removes all the material other than the wheat. Again, mostly it will be something like your grass and other things. So this is removed. And again, how do I do? I take so much weight. These are the foreign matter present. For example, 5 grams in 100 grams or 250 grams. So 5 by 250 percentage wise is the presence of foreign matter. Some of the visual grading aids are there. Visual grading aids will give an idea. That is how bright it is, how dark is it, etc. is the visual grading. Okay. So this will give an idea of the quality of a particular variety of wheat. Okay. So, what is done? The sample is put in a 5 by 7 inch photographic print on one side, and then the color is then compared with a standard color comparator. Maybe next semester or something, when you come here, you will be able to do it, and you will also be doing a similar work for your project. That is, you compare this with the standard, which will give an idea of which grade it is. Okay. Fine. So what does it mean here? This is what is done. So you have W1, W2, W3, etc., which gives now you see here, the damage can be because of the fungus, because of scab, frost damage, as I already told you, when there is a variation in temperature. So in that again, you have various classifications again. Within the frost damage, whether you have a candied one or a black or a brown one or a flake. If it is very light, then it is flaked, etc. Then you have the germ being damaged, and again that you can have whether it is because of the mold or other things. Similarly, these are the various grades. Now, how is it done? These are put on a photographic paper and a photograph taken, and this is then compared with the standard colors to then give, for example, here you will see this is because of fungi, this is because of physical factors. You see here, sprout damage is because of biological factors. Now, what happens, as I already told you, when the in the wheat, normally it is wet. When it is stored for a longer period of time, automatically then germination starts. So this is again undesirable. The other thing is, see, insectude or weevil, insects and weevils, etc. So each one has a particular thing. So a known weight of the grains are taken, and then these are characterized. Okay. Now, total defects are the grade determined, that is determined as a sum of all the things. So what are the things? Sunken and broken kernels, foreign material and damaged kernels. All the put together, we have the defects, and this gives the quality of the harvest that has been obtained. Now, other thing is, wheat of other classes is another grade determining factor. Now I have a particular wheat. Sometimes it can so happen that you can have other wheat variety getting inside. Now this is again, considered as a foreign matter, one grade determining factor. Why this is important? Again, as I already told you, the length to breadth ratio, the density, and everything varies depending on the wheat variety. So this is again one more important factor. Okay, fine. I think we'll stop here. Okay. Now we have also what is called as the mandatory non-grade determining factors. The grade determining factors include, as I already told you, the test weight per bushel, okay, or in other ways, weight of 100 kernels, etc., the length to breadth ratio, broken kernels, heat damaged kernels, okay, and presence of foreign matter. These are mandatory and these determine the grade. You also have something called as mandatory, but this does not determine the grade. This is not taken for grade determination. What is it? One is the moisture content. Because why? Moisture in it is high, it might lead to greater fungal or other differentiation, or it also can induce sprouting. And moisture, moisture, if it is quite high, can also lead to other problems. So moisture of the grain is a very important factor. Why it is important? Because whatever you weigh, I think you know, all your substances, all the matter in the world is more than 90% water. So if a buyer gets wheat and if it has a higher amount of moisture, so obviously, you know, if I have a wheat which has a moisture content of 10% and other has a moisture content of 16%, the one who buys a wheat of 16% actually is paying for that 5% extra of water. So normally around 12% moisture is taken as a standard for 12 to 14, if I'm right, is taken as a standard, because if going to be more than that, it is a loss for the buyer, because he is getting less kernels and it is only just something like adulteration with water. If it is going to be less than 10, then also there is a problem, because what is going to happen? The buyer will be getting more profit. So that is the thing. Now, how do I do moisture estimation in the case of cereals? We do it at 130 degrees centigrade for 2 hours. Now, conventionally, we do it at 105 degrees centigrade for 4 to 5 hours. Now, why this 130 degrees centigrade in this case? In the case of cereals, now the same method is followed for rice or wheat, etc. The amount of sugars are very high and starch is high. So when I'm going to keep it at 105 degrees centigrade for 4 to 5 hours, you know, obviously you have your Maillard reaction and caramelization reaction taking place. To avoid it only, we go for what is called as the high temperature short time procedure. So I keep it at 130 degrees centigrade for 2 hours to find out. Of course, I think you know, what is the standard time temperature combination for estimation of moisture in fruits and vegetables? Fruits, for example. Hello? Hello?
Yes, sir.
So what is the time temperature combination in the case of fruits or any product which has a very high moisture content? Leave alone fruit. Any product which has a high amount of moisture and high amount of reducing sugar content. Hello? See, somewhere you have to know the basics. You cannot, you know, what to say. You cannot say that, you know, like, you know, ask not what the country did for you, ask you what you did for the country, sort of. You can't claim that the department has done nothing. You have till now covered more than half of the, what to say, curriculum that is required for you. And if you don't have the basics, you cannot then claim that, you know, CFTRA, you get this placement or training, and X and Y get this placement and training. In fact, one of your seniors, I heard, you know, told that, you know, students in Kungu are better. Now, how students at Kungu are better? Because they come with a higher percentage of marks in 12th, as also they score better there. Now, who prevented you from not scoring well in your 12th or not scoring here or understanding here well? Somewhere it is, I don't know. Sometimes I get irritated when I get such comments, because it is the same people. Students are students. And when you say that, there they do it better, it is not because of the teachers, it's because of the students, right? All of us, you have gone through the same, milling and grinding. So all of the teachers have come from reputed universities and colleges. So the problem is not with the, what to say, with the teachers, it's more because of the students, right? Yes.